Hello. As our next task, we are going to create our first notebook, real notebook that we're going to use. And topic-wise, we're going into modules and how to import modules. We've seen this already with the datetime module, but a little bit more into detail on how to use the modules and how to import them. There's different ways about it. And for that we're going to create a new notebook. But let's keep it a little bit tidy. So we're going to create a new folder here on the top in our Jupyter Lab that we still have open, or just have to open from the Anaconda Navigator. The Jupyter Lab launch button opens up a web browser. This one here, the standard view, and here on the top left you can see a new folder button. If we click this, a new folder pops up. And we can call it just notebooks. If we go into there, there's nothing in there. And if we have the launcher here, we can click on under notebook, on Python 3 notebook, and open this and call it, right click on the title, rename the notebook, and maybe call it importing modules or something. Okay. So, Python itself, the core language, comes with very little that is useful to, for example, data scientists or scientists and so on. The Python itself is complete, so you can do everything with it, but there's a lot of functions, a lot of modules that you can import that make your life easier. For example, we had the datetime module that handles times. In general, once you import a module into Python, it will be present while you run the script. If you close it, you have to import and open it up again, you have to re-import it, right? At the same time, you have to make sure that this module or this additional functionality is installed in your Python environment. If it's not there, so most of the standard ones we are going to use are already in the Anaconda distribution. If they are not, for some reason, you can go to your Anaconda environment, and you see on the left hand side, in the Anaconda Navigator, on the left hand side you can see environments, and then you see the base environment that is currently running, and here you see all the installed modules, additional packages that are already installed, quite a lot of them. That's why Anaconda is quite big when you install it. But you can also search the uninstalled ones and then search for packages and then just click on install, and that's how you install packages. You can, in addition to that, you can also do this via the console. So if you're going to here, we're doing this from within the Jupyter Lab. You can just open up a terminal, and here then you can click conda install and then the name of the package that you want to install. But we're not going to do this now. We have most of the packages we need already pre-installed. For example, we had already the datetime module, but maybe let's start with a simpler one, the math module, right? If we want to do some maths, we can import math. Obviously, the normal math operations are already in there in the standard Python, but if you want to do more advanced math stuff, or want to have some constants maybe defined already, the math module is what you're looking for, at least for now. So if I import the math module like this, I have, for example, math.py, a new variable, which gives you just pi out of the box. Okay. When I used it before with the datetime module, what you saw was that I used a different syntax, import datetime as DT, right? Same thing I can do here. It's basically renaming a module that you're importing. If you have more complicated names, for example, for a module, it makes it easier to shorten it, that you don't have to type in the whole name all the time. For math, it's quite okay. It's just 4 letters, so you can if you just import math here, every function that is available, or every function and constant and whatever is in this module, is available with a dot after the name of the module, how you imported it. I could also import math as just M, for example. If I execute this, Shift Enter, I noticed that you notice that the 1 changed to a 3 here. So now the first cell, this here, is now the third that was executed. So this one is older, and I can change now change math.py to m.py because I renamed the module to m. And now everything that was available within the math module is now available in a module I called m. Right? I can also do a similar thing or a different thing. Instead of doing it like this, I can use kind of a wildcard syntax. So I can say from math import star or asterisk. If I do this, then math is not available, but everything that is inside the math module is imported directly into Python. So I don't have a m.py now, I have just py. Because py was in math and now it's in Python because it's without a prefix, right? It's just because I imported everything from there into my main namespace in Python, which is now called py. We can use also autocompletion to look for things in modules. Right? Let's maybe restart the kernel. Kernel, by the way, is you can imagine as an instance of Python running in the background, similar to the console. When you open one console and you type everything in, all the variables you declare are in memory. Similar thing happens here with the notebook. So everything that you run, everything that you run since the beginning of your notebook, when you first started it up, that is still in memory. For that reason, because nothing is overwritten, either it's overwritten or it's, in our case here, called differently. But because in the first instance I executed here was just import math, right? So now math is still available because I didn't reload the kernel or close the kernel, right? So now I can still do math.py, even though this is now called m, because from a previous execution, math.py is still there. However, if I restart the kernel, make a fresh restart, the numbers are still there because they're saved. But if I now execute this again, this cell, shift enter, and then m.py still works. From math import, we can also execute, shift enter, everything is the same. But math.py gives me now an error. We'll get to errors later, but this gives you an error now because math is not available on its own. It's just, we only imported it as m. So it's just named m, not math anymore. This should give you some idea of the structure of importing modules and how to deal with this. If I, however, by the way, escape, if I am in one cell, I press, you see it's blue, so it's in edit mode. If I escape it, the blue border around the cell disappears. And now I'm in one mode up, basically. So I can move with the arrows, for example, I can move between cells. If I am with this blue marker on the left-hand side here in one cell that I want to edit, I just press enter and I'm there. It's quite handy to look at these shortcuts. Here under help, you get quite a lot of help or references into how to use Jupyter in an easy way. Right. Okay. Let's import this math module again. Import math as math. And now Python is quite clever about it. So because we already imported it as m, it basically just links the names. So it's not too much burden on the memory, which is not that bad for like a small module like math, but it's more important for bigger modules later if you use them. So let's import math as math again, or just hit import math. This is the same, right? Then math.py is still available. I was talking about autocompletion. So if I'm not sure what function, what module, class or what constant I want to use from this math module, I just hit the dot, type the dot, and then hit tab, the tab key. In the Jupyter Notebooks or in Jupyter Lab, we also have auto-completion, which is quite handy because now we can, with the tab, we can cycle through all the different functions that are now available from the math module. It's quite a lot, and you can start at the beginning. You see, for example, sine, cosine functions, square root, some constants, and so on. A lot of math functions that you will actually want to use at some point, maybe. Okay, while we're at it, square root, for example, function, sqrt. Right? If I'm not sure how to use it, I mean, square root of 4 is just 2, right? It's quite easy to use. However, if I'm not sure how a function works, I can type either use the help function around any function, and it basically prints me out a little help about this, whatever I put in this help function, math.sqrt. Sqrt of x, return the square root of x. Quite easy. In this help function should work anywhere, independent of which interface you're using. In the Jupyter Lab and Jupyter Notebook and Jupyter Qt console, you can just type a question mark after it, and then you get a similar kind of information. So the signature of the function, it's called math.sqrt, and then of x, and return the square root of x is the docstring, and what kind of type it is, it's a built-in function or method. So it's a function. For more complicated functions or modules, you get more information, often also with examples. So these question marks, this question mark is quite powerful to you to look up. Similarly, you can also just use the open up one bracket, and then if you then hit tab, you get a whole bunch of possibilities. But these now include all functions that you, or everything that you could type in there. Right? That it's not; these are not restricted to just the square root function in this case. Okay, if you hit Shift Tab, then you get as a tooltip the same as with the question mark you would get when you print it out here. So if you just type question mark, then you get this. If I remove this, type one bracket, and then Shift Tab, a tooltip pops up how to use this function. If the function contains contains a nice docstring, a nice comment on how to use it. This is obviously the responsibility of the maintainer. If you write your own code, make sure to write nice docstrings that people know how to use your functions. Okay, so the square root of 4 is 2. Right? So we now imported a module, and we know a little bit how to import different things. These are, so how does Python know where this math module is? And this is taken care of by the Python environment. In our case, Conda, it's installed in a way that there's a structure behind it where Python can find different modules that are installed. This is taken part of Conda. It gets a little bit more complicated if you write your own functions and your own modules and then import them. You can also import them, so you can kind of modularize your code, but we'll get back to that later. It basically functions in the same way, just that you have to set the path in a meaningful way beforehand. Okay. You can import multiple functions or multiple modules, obviously, and it's good practice to, in the beginning, import everything. If you do something, if you import it later in the code, for example, if we want to import the OS module, the operating system module, let's call it like this, import OS here, and it is only available after you run it here, right? It's not available before. So it's a good idea to Control X and here Control V to import everything that you need in the beginning. It makes it easier for your code to be structured in a way, also to do checks if this module is installed, import it, otherwise do something else or give an error message or something. It's easier to do this in the beginning. So it's good form to always import stuff in the beginning. Okay, so this is everything I wanted to talk to you about for now, about importing modules and functions and so on in general. In the next video, we're going through data types, common data types. We already saw here the pi as a floating point number, so it's a decimal number, and we get into more detail in the next video about this. See you soon.